During this coursework we have looked at many different aspects about computers: installation of all the major working parts of the computer, configured and programmed the UEFI or BIOS, installed an operating system, customized the operating system, finally fault finding, maintenance and upgrading. We claim that all the clever stuff happens inside the CPU, but what's inside it? Exactly how does it operate and how does it make a decision? So, like we have said many times before, the CPU is the brain of the system. Also, there are other components such as RAM. Why does it lose the data held in it when the power is removed, then re-established when power is restored? We must turn back the clock and look at how a guy called George Boole came up with the theory called Boolean Logic. His theory is still used today to design not only how the computer systems work, but just about any electronic device that must be able to produce an effect on the information or input it receives. This could be anything from a simple television remote control to AI. George explored the possibilities of logic in mathematics called logic gates. He created a truth table, and from this just 3 symbols that followed very simple rules. These he called NOT, and OR gates. These have an input and an output. Depending upon the input, there could only be one single output. Here is a simple example. It's called an AND gate. The following has 2 inputs. We shall come back to this later and explain it in full, but for this example, when the input is 0 and 0, the output will be 0. But only when the input is 1 and 1, the output will be 1. At first sight, you will be forgiven to think how this oversimplified theory can have anything possibly to do with the landing of a spacecraft on the moon, or from being able to almost see to the far end of our universe. These gates can be combined to increase their complexity. This is an example of a gate. There's a combination of gates. It's called an XNOR gate. The output of this gate is 1 only when both the inputs are 0 or 1. This is not some random system, it is logic, and it is that we shall be pursuing during this coursework. How we can prove that these symbols will behave in a special manner using theory and a practical example. It wasn't until 100 years later, during Second World War, a German guy called Konrad Zuse came up with the idea that the theory of logic created by George could be used in a computerized system. In fact, a lot of people recognize him as being the founder of modern day computer systems. He called his system Z3. The Z3 system could complete multiplications within 3 seconds, and the output were on punched celluloid tape. It consumed 4,000 watts and weighed in at 1 ton. It had 2,000 industrial relays that would have operated between 5,000 to 10,000 times per second. Unfortunately, as with a lot of things happening in the 40s, sadly the V3 was bombed and destroyed. This coursework is split into 3 parts: the truth table, the schematic diagram, how the inputs and outputs are arranged, then a real-life practical example that will include some electrical and electronic assembly, giving the proof that the theory of logic gates is sound.